Okay, so we'll proceed in pseudo calculus problems. Okay, so idea is to take calculus problems one by one and solve it. But somehow we are hanged in the first problem only. And solving the first problem thoroughly would certainly help the other problems. What we are seeing right now when we are solving the surface area of a circle, when we are seeing surface area of a circle, where we started with the height into width is the area. From there, we went with the single dx integration. Only one independent component, that is dx, and integration with that. And then we saw dx dy as integration. Then we saw d theta dr as integration. That we saw in the spherical coordinate, I'm sorry, polar coordinate system and then cylindrical coordinate system. Now we are seeing in the spherical coordinate system. What we have seen as far as the spherical coordinate system or any coordinate system is concerned, if I have a position vector of any point, then d of p, if position vector is on a line, if I have a, this is x-axis and this is a line on x-axis, this is origin, this is x-axis, this is origin, and this is a line. This point is P. Then what is the position vector? This line, this is a line, and on this line there is a point called P. What is the vector representation of P? Connecting origin and point P, I can directly connect through a vector, and that is the vector representation of a line. Anyway, or if I have a curved line, if this is x-axis and there is a curved line, on this curved line, if I have a point P, then what is the kind of vector representation of a this line when we talk? I'm sorry, I would rephrase it. If I have a point on a line, line can be a straight line or line can be a curved line. Okay, in that fashion, if there is a point P, then point P represent a line. If point P sits on a curve surface, then point P represent a surface. Many ways we have found out the surface area of a circle. Many ways, not one way. Many ways we have found out the surface area of a circle. And in that way, one way is also that is trivial, that if I have a point P on a curved line P, then P represents a curved line. If I say I have a point P on a surface area, then P represents a surface area. A line that connects origin and point P. I believe it makes sense. Okay, consider this is a sphere and this is centered at the origin. This is sphere centered at the origin. If this sphere is centered at the origin, then from the center of the sphere, if there is a point P here, if I draw this line, that is called position vector. And this point P on the surface is called a point on a surface point. If I from origin, if I draw a line, consider this point is x comma y comma z. This point is x comma y comma z. From origin, if I draw a line, then that vector position vector p, capital P, on top of it arrow mark. This is called position vector. Then position vector is xi plus yj plus zk, considering p is x comma y comma z. Considering p is x comma y comma z, if I draw a line, then that is xi plus yj plus zk. That is called position vector. That is called position vector. If that is called position vector, this position vector represents a point P on a surface. This can be said as this is a surface vector. This is a surface position vector. This is a surface position vector. I believe is it all right. This is a surface position vector. Now, if I have a line position vector, if I have a curved line, Okay, if I have a curved line like this, and this is x-axis, and there is a point P here, this P represents a point on a line. If from origin, this is origin, if I draw a straight line, this will become a position vector. Position vector of a point on a curved line, this position vector represents a curved line. If there is a position vector on a surface, 3D surface, and from center if I draw a line, this position vector represents a surface area position vector. Okay, means both are xi plus yj plus zk, both. If I say xi plus yj plus zk is my position vector, then anyone would ask this, your position vector represent a line or your position vector represent a surface area. Okay, if that is the case, if I have a position vector, if that is the case, then if I have a position vector like this, if that is the case, and if I have a position vector like this P here, if I have a position vector here P here, and there is a straight line like this and P here, now in that fashion, this position vector, if I calculate differentiation of this position vector, please watch our previous videos, we have proved it. If there is a position vector like this connecting this point P and origin left side, and if I calculate derivative of this position vector, if I calculate derivative of this position vector, it will represent another vector. If I have xi plus yj plus zk, that is a position vector. If I calculate derivative of this position, d of xi plus yj plus zk, dxi plus dyj plus dzk, this derivative of position vector is another vector, and that vector will be at point P along the line. Everywhere it will be along the line. If this is the point P and this is the position vector, this will be along the line. This will be along the line. This will be along the line. Everywhere position vector derivative will be another vector that will be along the line. If that is the case, if that is the case, then differentiation of position vector gives another vector along the line. If I have a position vector, if I have a position vector P here, and this is, I have a point P here, and consider this is centered at the origin of this and P, if I draw a line, that is position vector. Derivative of position vector will be another vector that will be along this line or surface. D of P represent a position vector on the surface, give the surface area vector. Okay, anyway, we calculating the magnitude of surface area vector gives the surface. If I take any point P here, xi plus yj plus zk, and if I calculate derivative of this, that is dxi plus dyj, d of position vector, d of xi plus yj plus zk, that is dxi plus dyj plus dzk. If that is the case, then this vector, the new vector that is coming d of p, dxi plus dyj plus dzk, d of position vector, d of in bracket xi plus yj plus zk, d of position vector will result into another vector, and that vector is surface area vector. Okay, you said I'll calculate the magnitude of surface area vector and it will give me the surface area. Okay, is it the case? Certainly. Oh, then dxi plus dyj plus dzk, that is dx square plus dy square plus dz square root, will give the surface area of a surface area. Certainly, it will give surface area. Anyway, now then we saw that d of p, when p is in Cartesian coordinate system, d of p is same as d of p by d of r theta into d of r theta. Simple mathematics, right? Y equal to y into x by x. D of p is same as d of p by dr theta into dr theta, or d of p is same as d of p by d of theta phi into d theta phi. Whatever comes to your mind, you can take. We are taking theta r because we are trying to calculate surface area of a circle. And if this is a sphere, consider this is a sphere, and sphere is centered at the origin, means xy plane will cut a sphere exactly at the center. Top hemisphere of the sphere is above the xy plane and bottom hemisphere is below the xy plane. This will cut it. And now on the xy plane I have origin, that is 0, 0, 0. It will go inside and it will coincide with the 0, 0. It will coincide with the origin center of this sphere. Now in that fashion, I take any point P here, d of P by d r theta. If I'm trying to calculate the surface area of a circle, then if I cut it, then it will form a circle here with radius r. If I cut it, then it will form a circle here with radius r. If it forms a radius r, I'm sorry, radius a. Consider the radius of this sphere is a. Okay, radius of this sphere is a. If that is the case, if I cut at the center, then there will be a circle with radius will be a. Radius will be a and it will be a circle. What is the area of the circle? Someone will say, if you cut anywhere, it will be circle one only. If you cut at xy plane, then circle radius will be a, that is the radius of the sphere. Otherwise, if we cut little above, then it will have different radius. If I say r is the radius at any height, then that is the area will be the surface area of the circle, that will be here. Now, in the spherical coordinate system, there are three coordinates. Three orthogonal components are there. One is radius, one is theta, that is in theta r plane, and one is phi with the vertical. There is a vertical. If it has an origin, and this is the topmost point. If I draw a straight line, it is called vertical. K. This is x. This is y. This is I vector. This is j vector, and this is k vector. Now, if that is the case, then this will be xy plane and this will be z plane. Z is dependent upon x and y. This is in Cartesian coordinate system. Anyway, in a spherical coordinate system, no one is dependent upon anyone. R, theta and phi. Phi is from vertical. Whatever angle it is making, it is the phi. Now, if I say this is xy plane, I am cutting a plane here, and it is at angle phi. If this is the vertical, then angle phi is 0. Now phi is growing. Now it is 90 degree. This is xy plane. If phi is growing and it is at some phi, if that is the case, then if I draw from the center, it will come here. If I cut it here, then there will be radius r. So at any angle phi, if I make a cut in the sphere, what is the area of the circle? This is what I am trying to find. If phi is 90 degree, then area of the circle will be the circle where radius will be the radius of the sphere. But if angle is not 90 degree, then area of the circle will be r and it will not be a, that is the surface area radius. I believe it is all right. Now in that case, what is the surface area of a circle at any angle phi in a spherical coordinate system? The special case is phi equal to 90 degree and then radius of the circle is the radius of the sphere. Okay, now we have talked about dp, d of p position vector is the area vector. If I take any position vector here x, here p, then it is xi plus yj plus zk. D of xi plus yj plus zk is the surface area vector. Calculating the magnitude of the surface area vector will give the surface area. Anyway, this is very much in abstract term. D of P is same as D of P by D theta r. Why I am saying D theta r? I am trying to calculate a surface. I am trying to estimate one surface that is in theta r plane. So this is theta r plane, and this is radius, and this is phi radius plane. This is radius. I would rather say, if this is radius of the sphere any time, then this is the angle with the vertical phi. This is r sine phi that will fall on the xy plane. This is r sine phi theta plane. This is better word. This is r, then this is r phi plane, where this r is r into phi. r sine phi will fall if this if this vertical it is making phi angle. With vertical it is making phi angle, then vertical is r cos phi. R sine phi will fall on xy plane. Now r sine phi theta will be arc in the xy plane. These explanations are not available in any of the books. Now r sine phi theta is this plane. R phi is this plane. Okay. Now in that fashion, if I talk about area in this plane, then we are talking about r and theta, or r sine phi and theta. Okay, in that fashion, we will take d of p, that is the area vector. Now we will divide it by d theta r, because we are interested in theta r, not on the phi. If I say theta and phi, it will make this surface area. If I take r and phi, then it will take something else that I don't know. Okay, I believe if I take r and phi, this is r and this is phi, it will take cross this area. In r phi also, I can calculate the surface area, and their radius is a, and theta is fixed. R and phi. Someone can try r and phi also. Right now I am taking theta and r. So dp is the area vector. Then dp equal to dp by d theta r into d theta r. Please watch our previous video. dp by d theta r is same as dp by d theta cross dp by dr, because we have taken, now we are taking three things into the consideration. One is theta r plane, one is xy plane, and top of xy plane we have a surface here, point P here. Okay, dp by d theta means at point P how much area is changing if I make 1 unit of area change in theta r plane into d theta r. If I make one, if this is theta r plane and this is xy plane, they are related to each other. X equal to r sine phi cos theta, y equal to r sine phi sine theta. They are related. In that sense, if I take theta r plane and xy plane, if I have a rectangle here that will correspond to a circle here, and this circle on xy plane will correspond to a surface area here, because if I see from the top of this sphere, it will form a circle on xy plane. Now if I make a 1 unit of area change in theta r plane, it will make some unit of area change in xy plane, because there is a relationship. If there is some unit of area change here, then there will be some unit of area change at point P, dp by d theta r. If I make 1 unit of area change on theta r plane via media xy plane, how much area change I see around the P, dp by d theta r. That is dp by d theta cross dp by dr. Okay, into d theta r will transform into d theta dr. Please watch our previous video, previous 5 or 6 video. Somewhere you will get. Or try watching the pseudo multivariate calculus. This is pseudo calculus problems. We're tackling problem by problem. But theoretical part we have covered is the pseudo multivariate calculus. Why dp by d theta is dp by d theta cross dp by dr. Now we will take dp by d theta cross dp by dr into d theta dr as the area vector. Now this area vector is in theta r plane. This is what we want, in theta r plane. Okay, with phi as variable. Now P is xi plus yj plus zk dp by d theta cross dp by dr. Now P is xi plus yj plus zk. X is r sine phi cos theta. So P is r p d of r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k by d theta, and it will become d of d sine phi minus sine theta I plus d of sine phi cos theta j plus d of r cos phi by d theta. That will be 0 because phi is not varying with the theta. At the end we have dp by d theta is r minus r sine phi minus sine theta I plus r sine phi cos theta j. cross product with dp by dr, that will be called sine phi, sine phi cos theta I, r will go away, sine phi sine theta j plus cos phi k. If I do cross product of these two, if I take cross product of these two, one is r, I'm sorry, r sine phi minus sine theta I plus r sine phi cos theta j. Hope, I believe I am alright. Cross product with sine phi cos theta I plus sine phi sine theta j plus cos phi k. If I do cross product of these two, I'm not running away, we'll do the cross product. Okay, r minus sine theta, r minus sine theta. Okay, we are interested in k vector only because r theta, the area vector will be k vector, not the other vector. Okay, that is the scenario. Anyway, dp by d theta, dp by d theta and dp by dr. If I take the k vector, we will not consider other vector because we are trying to calculate the area of surface area in theta or plane where the area vector is perpendicular to the surface. Area is like this, the perpendicular to surface will be k vector. So only we will take k vector. Now we have I vector, and if I want k vector, it will get cross product with the j vector there. If I do the cross product with the j vector, then what it will become? I cross j will become k. Here we have r sine phi minus cos theta. There sine phi, r sine phi minus sine theta. There r sine phi cos theta. Up, r sine phi sine theta. It become r, I'm sorry, r is not there. It become r sine square phi minus sine square theta. Now first one j term and this side I term we will take. J cross I will become minus. It become r sine square phi cos square theta. If I do cross product of these, if I, now this is k, this is k. If I add this, it will become minus r sine square phi cos square theta plus minus r sine square phi sine square theta. If I add these two, it will become minus r sine square phi k vector. Other vector I am not interested in because I know that area vector for the theta or plane is the k vector. Now d theta, dr. Now we have r sine square phi d theta dr k unit vector. This is the area vector we are interested in. If that is the case, then what is this area vector? Okay, I'm sorry, what is the magnitude of this area vector? Magnitude of this area vector is k will go away. R sine square phi d theta dr is the area vector. Now, if this is the area vector, will it give the area? In the xy plane, it will give in every cut. If I make any cut at angle phi, it will give the area. Or sine square phi. Okay, or sine square phi. Okay, if that is the case, if someone want to proceed, he can proceed with the other cross also. I cross I0, I cross J, we calculated. I cross K will result in the J. And this side J cross I, J cross J, J cross K will result, would result in the J cross K would result in the J. What is I component? Here this side I and that side k. R sine phi minus sine theta. And there cos phi. Sine phi cos phi sine theta. And j cross I is r sine phi. I'm sorry, j cross k is r sine phi cos phi cos phi cos phi cos theta, sine theta, cos theta. So one is r sine phi cos theta, one is r sine phi cos phi sine theta, and one is r sine square phi. If I just take all along, if I just take all along, then it become r. R will come out sine to the power 4 phi, and then sine square phi cos square phi. Okay, cos square theta sine square theta will become 1. Means sine square phi plus sine square phi cos square phi. If I take out sine square phi, then it will become sine square phi plus cos square phi. It is 1. It will become sine square phi only. If I do the full cross product, it will become r sine square phi only. Anyway, but we are interested only in k vector, because it will turn as k vector, I vector, j vector. Means this is what it is saying. Anyway, now we have area vector in r minus r sine square phi k unit vector d theta dr. If I calculate magnitude r sine square phi d theta dr, where theta is from 0 to 2 pi and r is 0 to a, it becomes r dr will become r square by 2, and theta d theta will be 2 pi, 2 gone, pi a square, pi a square, pi a square, pi a square sine square phi is the area of the flat circle. Now pi a square sine square phi, when phi is 90 degree, when phi is 90 degree, then it is pi a square, that is the area at xy plane. If phi is 45 degree, then it is pi a square sine 45 is 1 by square root of 2, 1 by 2. If it is 1 by 2, then it is pi a square by 2. Means at 45 degree pi, the area of the circle will be pi a square by 2. At 90 degree, it will be pi a square. What about at 30 degree, 60 degree? Anyone can calculate. What about 0 degree? At the top, there is no circle. Okay, now people can consider calculating the area of a circle. Calculating the area of the circle. Okay, this someone can take as a home. What is assignment? What is the area of a circle of a sphere in r phi plane? R phi plane. If this is radius and this is phi, it makes a r phi plane, that is again a circle which have full radius as a only. Okay, at any fixed angle theta r phi. In that sense, d of p will become d of p by d theta. D of p will become d of p by d of p. I'm really sorry. d of p, d of p by d r phi into dr phi. If someone takes this d of p by dr phi, r phi into dr phi, someone can calculate area of a circle in this fashion only. We will talk again in pure spherical coordinate system. We were trying to calculate the surface area of a flat in pure spherical coordinate system. If it is a pure spherical coordinate system, then again it is dp by dr theta. dp by dr theta. If it is dp by dr theta, we took different approach. We took approach where we made a cut in phi r plane and we made cut in phi theta plane. If we are calculating a surface area in r and theta, phi we consider as constant. Anyway, if I take any point P here and I make a cut in phi theta plane, if I make a cut in phi r plane, then it will make a two curve line. And any point P, if I have a two curve line at any point P, taking the cross product of these two curve lines, we give the surface area vector, and calculating the magnitude of surface area vector will give the surface area. One surface area vector is r unit vector plus r sine phi theta unit vector plus r phi unit vector. This is what we talked about in pure spherical coordinate system. dp by d theta. I'm sorry. This this is a curve line equation for a curve in phi theta plane. In phi r plane, again r unit vector plus r sine phi theta unit vector plus r phi unit vector. If I take cross product of these two, if I take cross product of these two, then it will give the surface area vector at any point P here in pure spherical coordinate system. First side we will take out theta and another side we will take out r. Then first side division I will convert into differentiation and multiplication I will convert into integral calculus. This is pseudo multivariate calculus. Now in that fashion it becomes dr by d theta. Theta I have taken out from the r unit vector plus r sine phi theta, theta unit vector plus r phi unit vector. If I take out theta, it becomes r by theta, theta unit vector plus r sine phi, theta by theta gone, theta unit vector. R by theta, r unit vector, r sine phi, theta unit vector plus r d phi by d theta into d theta. Cross product r I have taken out. So that will be dr by dr means r unit vector. Take out r from r unit vector plus r sine phi theta unit vector plus r phi unit vector. Take out r and convert division into differentiation and multiplication into integral calculus. It will become r by r, that is r unit vector, plus r sine phi theta by r d theta by dr theta unit vector plus r phi d phi by dr phi unit vector into dr. Now if I do cross product of these two, first will become dr by dr r unit vector dr by d theta. Here r is constant in phi theta plane 0, d phi by d theta 0. Only remain is r sine phi theta unit vector, r sine phi theta unit vector, and this side r unit vector plus r sine phi theta unit r sine phi d theta by dr 0, because it is theta is constant here. D phi by dr 0, because phi and r are not related to each other. 0. It will become r unit vector. Now we have cross product of r sine phi theta unit vector cross r unit vector. Now we are doing cross product of these two, r unit vector, cross product of r unit vector and theta unit vector. But we want r unit vector as this r unit vector because we are trying to calculate surface area in theta r. We have given other explanations also. There is another explanation also. Please watch our previous video. If this is the theta r plane and we have taken r a anywhere because we are talking about a sphere, that is r unit vector. This is not r unit, but we want this as r unit vector, polar coordinate system. Then we will have theta unit vector, that is r, and r unit vector cross product will give the vertical unit vector. Then if this is r unit vector, r sine phi will give this r unit vector in xy plane. Now it will resolve into r sine phi theta unit vector cross product r unit vector. Instead of r unit vector, we will write it as sine phi. R unit vector is same as 1 into r unit vector. 1 is the radius, 1 sine phi means sine phi r unit vector. Dr d theta, it will come as r sine square phi dr d theta vertical unit vector cross product of theta in xy plane. If this is circle, theta in xy plane and r vector. This is r vector, r sine phi falls here. This is, now we have r sine square phi d theta dr. Same thing what we did right now, and it will give as pi a square sine square phi is the area of a circle that will be at any angle phi. That is same as we also talk. If this is perpendicular and this is phi, then this radius, temporary radius, is a sine phi only. A cos phi is vertical, a sine phi is this radius. Area of any circle at any point of angle phi is pi r square, that is pi a sine phi square, pi a square sine square phi. Same thing what we calculated. Anyway, that is an assignment and we will proceed in more in it. That calculate the area through dp by d r phi, so that in r phi we will get the circular area. Amazing, mind blowing. We will take very interesting example in pseudo calculus problems. Please don't mind supporting us +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.